Hello, welcome to Pre-Technical Mathematics. This video lecture is on graphical and algebraic methods for solving linear equations. Chapter 6, Section 2. This video is fairly lengthy, so please allow enough time to view the entire video. Okay, stop or pause the video at any time to examine the material more thoroughly. First, we'll get started with the graphing method. You learned earlier that we needed the graphing form to be in the form of the slope-intercept formula. And let me remind you that that was y equals mx plus b. So the first thing we need to do is take each one of these equations and change it into the yx plus b format. So let's see if we can do that. We'll take it step by step. 2y equals, we'll put the negative 3x over here in the area that we need it in, plus 2. And then we divide the whole thing by 2. Remember, this becomes a fractional slope and a fractional, I put that the wrong way, didn't I? Whoops, I'm sorry, I'm thinking that's 3. I don't know where my mind is here. 2 divided by 2 is 1. That's our y-intercept. That's much better. Okay, keep me straight. Alright, now let me try and do a better job on this one. 6y equals, we'll put the negative 2x on this side, and the minus 39 we carry. We divide by negative 6, we end up with 1/6x plus a not so nice fraction, 39/6. We can work with that. Alright, now the trick is to graph it. Let me show you how this works. I wish I had a grid system. It would make things a lot easier. Let's start with this one. The 1 is the y-intercept. So y equals 1. That's this point right here. Now the slope, remember I told you it was the rise over the run. Okay, so we're going to rise, or actually in this case we're going to go down 3 and to the right 2 because it's a positive 2. So we start here at the y-intercept. We go down 3. 1, 2, 3. And we go over to, in a positive direction, 2. 1, 2. So down 3, over 2. That is our next point. We go down 3. 1, 2, 3, and over 2. That is our next point. Okay, so it's rise over run. In this case, a negative rise. Then we do a hopefully good job of connecting these lines. Okay, that's our first line. Now we've got 1/3 x over 39/6. Well, let's see. 39/6 is 6 1/2. Okay, that's a little harder to find, but let's see, 1, 2, 3, 4, 5, 6, and 7. And we're right about here. That's our y-intercept. Now let's look at our slope. We have a rise of 1 and a run of 3. So we're going to rise 1 and run 3. 1, come on, 1, 2, 2, 3. Rise 1 and run 3. Rise 1, we'll put another one in here for good measure. 1, 2, 3. That is our second graph. Now let me see what I can do here. There we go. Now if you do this on grid paper, which I highly recommend, you're going to be able to find this point exactly. It's a little bit difficult in this particular problem, but I'll tell you what it is. That point represents the x and y values that solve these two equations simultaneously. And that point is -3 and 11/2. Okay, so that point, if you put in -3 and 11/2, you will come out with 0. If you put in -3 and 11/2, you will come out with -39. This is the point that solves these two equations. Alright, now we're going to move on to another method, solving by substitution. Solve one of the equations for one of the variables. Substitute solution from step 1 into the other equation and solve for the remaining variable. Substitute the value from step 2 into equation from step 1 and solve for the other variable. It sounds very difficult, but it's really not. Let me show you how it works. Okay, here we have two equations again. And I know you're going to like this once you get used to it better than the graphing method, but it's important for you to understand the three methods of solving linear equations. So let's use the substitution method. Now luckily, we already have an answer for x. And it says to substitute that, solve for one of the variables, which we've already done, and then substitute that in to the second equation. So let's write that out. 3 times 7 plus 2y plus 4y equals 1. And we know how to solve this from the earlier sections. We end up with 21 plus 6y plus 4y equals 1. We'll combine the y's into 10y, and we'll subtract 21 from this side, giving us a -20. So what does y equal? Right, -2. Now we've got our value for y, but we still need to find the value for x. So we'll put this back into that equation. X equals 7 plus 2 times our y, -2. And we'll get x equal to 7 minus 4 is 3. So our point that is that solves both these equations simultaneously is 3, -2. Now, I know what you're thinking. This is a lot easier than the graphing method, isn't it? Okay. Let's see. I've got one more with the substitution method. That's not quite as simple, so you may change your mind. Okay, number 16. Now, this is not as easy because we don't have an x equals or y equals. We've got a difficult equation to start with that we must make into an x equals or a y equals. We need to solve for one of the variables. Alright, let's take this one. So we'll get, I'll start over here, x equals a -2y, put that over here, minus 3 divided by 2. And we'll just leave that at this point so that we don't end up with messy fractions to work with. Alright, now the idea was to solve for one variable and then put it into the second equation, substitution. So we have 4 times -2y minus 3 over 2 plus 9y equals 5. So we've got okay, I'm sorry. A little phone call. Okay. So where were we? Okay, notice that this 4 and this 2 simplify, and it makes our equation very nice. So let's rewrite that as 2 times -2y minus 3. We've still got our plus 9y equals 5. So we've got -4y minus 6 plus 9y equals 5. Okay, we've got to combine like terms, and we get 5y. We'll add 6 to both sides, equals 11. So y will equal 11/5, which simplifies into 2.2. Okay, that is our y value. Now we still have to figure out our x value. So we want to take this y and dump it back into our x equation. So we'll go over here. X equals -2 times y, which is this one, 2.2 minus 3 divided by 2. And after you put that in your calculators, you should come up with -7.4 divided by 2, which equals a -3.7. So not quite as easy as the last one, working with this big equation to substitute in, but it turned out very nice when we simplified it. Okay, so what was our point that solved both equations? It was x as -3.7 and y as 2.2. That is the method of substitution. You ready to try one? Sure. Sure you are. Okay, here's one. You're going to have to solve one of them for x or for y. I suggest you solve for x. Pause or stop the video, try the problem, and check your answers with course documents. Okay, we've learned two methods so far. The method of graphing for two equations and the method of substitution for two equations. Now this one is the last one, but you're probably going to like it the best. Add or subtract the two equations in order to eliminate one of the variables. It is sometimes necessary to multiply the original equations by a constant before it is possible to eliminate one of the variables by adding or subtracting the equations. Again, very wordy, but you'll find through the example, I think, that it's not as difficult as it sounds. Let's see, let's get a problem up here. Okay, here we are. 3x and 2y. Now, what we want to do is we want to get one of these variables by adding these two equations together to cancel each other out. So we have a negative 2y here. If we add this equation, we need this to be a positive 2y. Okay, we can multiply any equation by a constant and it will remain an equivalent equation. So let's see how that's done. Let's rewrite this one because we're not doing anything to this one. 2y equals 8. Now we're going to multiply both sides of the equation by our constant. So we end up with 2 times the 5x gives us 10x. 2 times the y gives us a positive 2y. That's what we were driving for. And 2 times the 9 is 18. Now you simply add these two equations. So we have 3x plus 10x is 13x. Now look at this. This is what we're looking for. We cancel those out. And we add this and we get 26. So what we're left with is only one variable. 13x equals 26. And we can simply determine that x equals 2. Alright, now you've still got to go back and put the x in one of the equations to find y. So we'll put it in this top equation. It does not matter which equation you use, you'll arrive at the same answer because remember that this x is common between the two equations. So we'll just put it in the top one. Minus 2y equals 8. And what do we have here? We'll keep the 2y and we'll take the 6 to the other side. We'll end up with 2 and y equals negative 1. So our answer is 2, negative 1. I know you like that method. Okay. Let's try another one. Not so easy this time. We don't have an easy way to cancel out, well, not too bad, our x's and our y's. What can we do here? We have a positive 6 here. We need to make this a negative 6. So what do we need to multiply by? Negative 3. We will multiply the entire equation by negative 3. So what do we end up with? negative 6x plus 9y equals negative 33. Now we don't need to do anything to this bottom equation, so we'll just rewrite it. 5y equals 13. Then we simply add the two equations. Our x's cancel out this time, and we end up with 4y equaling a negative 20. So our y equals negative 5. Alright, not too bad. Okay, we need to put that y back into the equation to solve for x. So we have 2x minus 3 times negative 5 equals 11. And we have our 2x. This becomes 15. We subtract 15. And we get negative 4. Therefore, x equals negative 2. So we'll write our common point, or our common solution. Negative 2, negative 5. Okay, let's give you one to try. Okay. Remember, you're canceling out one of the variables by adding them together and ending up with one variable. Check your answers in the course information. Okay, we're not done yet. We're going to get a little more complicated, but use the same theory. Now we have a 6x and an 8x, and a 12y and a 15y. Neither one is very simple to eliminate. So what we have to do is multiply both equations by a constant in order to get them to drop out. Now the common multiple between 6x and 8x is 24x. So we want to get both of these to 24x. We'll multiply the top equation by 4. And we need this to be a negative 24. So we'll multiply the bottom equation by a negative 3. Let's do the math. We get 24x plus 48y. Remember, you're multiplying every term. And a common mistake, don't forget this last term. 28. Okay, negative 3 gives us our negative 24x that we're looking for, plus 45y equals 3. Okay, we add them together. We like that. We end up with 93y equals 31, which gives us simply y equals 31 divided by 93, which is 1/3. Okay, we need to find x. So we have 6x plus 12 times 1/3. Oh, I thought that fraction was going to give us trouble, but it really doesn't. Equals 7. So we have 6x plus 4 equals 7. And 6x equals 3x equals 1/2. So our common point that solves both equations, our x is 1/2 and our y is 1/3. And I really would have hated to do this one graphically. So here's another method. Okay, I'm going to give you another one and let you try it. Alright, find the common multiple. Multiply each equation by a constant so that one of the variables drops out. Doesn't matter whether you do the x's or the y's. It doesn't matter. This is the end of the video lecture for 6.2.